हेलो गाइस, वेलकम टू द नई वीडियो। आज हम देखेंगे टीयूसी के कुछ टॉपिक्स हैं जो गेट की प्रिपरेशन जो बच्चे कर रहे हैं उनके लिए रिवीजन टाइप मान लो। ठीक है, हमने जो आज ये टॉपिक जो हम कवर करेंगे वो रेगुलर लैंग्वेज, फाइनाइट ऑटोमेटा एंड डीएफए। सो लेट्स स्टार्ट। So what is regular language? Regular language can be expressed in terms of regular expression and finite automata or regular grammar. These are three ways to generate. Also, we can say generate a regular language or to express, we can say, or to identify. To identify, we have to check validity. All right, these are some functionalities of regular language. Right. So next is, let's say this is AX, BX, triple AX. X could be anything. Anything means uh, AVX, XAXB. These are all regular languages. We saw in previous uh, this could be any string, right? X is any string. A string contains A, contains B, contains double A, contains AB, triple A. So length of W string is equal to, right, less than is equal to 2. These are all functions. We can say the number of A's is equal to less than is equal to 2. Greater than equal to 2. These all are regular, we can say, expressions, right? Regular expressions to express regular language, right? So we see in the next is number of length of string, even, odd, number of particular symbol is even, odd. We always see in this regular language, right? What next is, what is this finite automata? So finite automata is two types. Right? It is used to validate, recognize regular language. Right? Recognize regular language. So these are two types of finite automata. By default, it is without output. But if we mention, it will. If we say by default, this is finite DFE. I mean finite automata. So it will be without output finite automata. If we mention specifically, explicitly, that it is not without output, it is with output, then we jump into transducers, right? So this is uh, with output is of two type, Mealy machine, Moore machine, right? In this, without output acceptors, this is called transducers also, with output, right? So DFA without output finite automata is of two types. First is DFA, deterministic finite automata, right? And second is NFA, non-deterministic NDFA or NFA we can say, right? Non-deterministic finite automata. Or and NFA is also of two types. First is without epsilon, means without epsilon. Epsilon. What is epsilon? Zero length string. All right. Epsilon zero length string. So first is without epsilon and second is with epsilon. So we will start with finite automata first. Definition. We'll see definition, configurations, representation. What is a representation? DFA versus NFA. Right. So let's see what is finite automata. It finite automata. If a machine, all right, finite automata machine we can say also is this machine. So it takes a string as input, all right, input string, and finite automata will accept this string if w uh, if the string belongs to the language. So listen again, I will explain. If this machine is built to accept the language L, all right. So if machine accept L, then if that string belongs to L first, then FA holds at a final state. Right? There will be a final state. We will see further this, right? What is final state? But it will holds in a final state. All right. If W does not belongs to L, which for which the machine was built, then uh, if it does not belongs to L, F holds at a non-final state. All right. It will hold at a non-final state. So when it holds at a non-final state, it means it is an invalid string, right? And it does not belongs to L, right? And if it holds at a final state, that means W belongs to L and it is accepted, right? So what is again? This is the, let's see, L is this, all right? L is AB and this is X. Let's see further. So this is a language, all right, regular language, or we can say any language. So all strings all start with AB. So what is segment star? Epsilon, A, B, and these are infinite strings this can generate. But the regular our finite automata only uh, build to accept those strings which starts with AB. So this way machine will not accept this. This will not halt at final at all. Like this will halt at final, and this will halt at final. This and no one else. All right. So yeah. So and there will be many number of, so only those strings which start with AB will hold to at final. All right. So other will not hold at final. Right. So what is again finite configuration? So finite configuration are finite automata configurations क्या होती? What was it? These are five tuple, alright? Five attribute tuple it is. It's a five attribute tuple. Finite automata. Alright? First what is first? Q, set of states. Alright? We will see further what is state and what is not. And sigma input alphabet, we saw it already. Alright? This is transmission function. Q naught initial state, alright, which belongs to Q, alright. Q naught belongs to Q because Q is a set of state or it is initial state, is a special initial state from which execution of uh, uh, I mean acceptance of string starts. Alright. F is a set of finals. It means it's a set of finals. It is not one. It could be more than one finals. Alright. Yes, it could be more than one finals. So let's say this is a string, our string, and this is finite control also. This is a structure we can say. Right? This is a reader. First it will read first character of the string, then it will go to next, then next, then next, then next. If at end of the string, all right, at end of the string, it holds at final. Then the string is accepted, otherwise the string is invalid. All right. So we will design uh, a finite automaton. Uh, each Q is equal to set of state which is 1 and 2. Alright. Input alphabet set of input symbols is A comma B. Transmission function this. Initial state is 1. Right. So here mm, first is A. It will this is initial state at A when the input is A and we are at initial state, then it will remain at uh, first state only, right? A. But when it is goes to 2, right? When it goes to 2, B, it is input is B, then it turns its transition goes to state 2, which is final state, and when it at we when we are at stage 2, state 2, so whether the input is A or B, we will remain at state 2, and which is accepting state. All right, accepting state, yeah, final state we can say. Final is 2, and F belongs to Q. F is set of final states. Mhm. There could be zero finals also. Number of finals are zero, which is also possible. Right. So let's see what's next is finite automata. And finite automata is two type, in which DFA and NFA. In DFA, the transition function is there. We will be at a state, whether whatever is that state is, we will uh, take an input symbol from input alphabet or a string, right? Then we will transit to next state, right? Current state, and this is next state. Next state. We will transit at next state, and there will be a rule for this. All right. NFA without epsilon moves in non-deterministic finite automata is we will see this after that. All right. This is the transition function. So let's see how we can represent state diagram. We can represent the finite automata. All right. We can state diagram, or second is transition table, or a third way of representing F is set functions and relations. we can say that this is our state diagram. One we saw it already. Initial state, and this is final state. So initial state could be final state also, right? And vice versa. And we are seeing that this is final. How can we identify final? By this. Double circle means final, right? How can we identify initial? By this, right? Arrow with the circle, right? This is final state, non-final state, this, only circle. Transition will be present state, this is next state, I will be input symbol, alright? How can we represent with table? This is transition function. When we are in a initial state and input is A, we will remain at 1. Alright. When we are at 1, state 1, input is B, we will transit to 2. Alright. When we are at 2, input is A, we will remain at 2. As we can see, we will remain at 2. Input is B, we will transit to 1. This is other way of representing. Alright, finite automata. How can we represent with, alright, set function? So this is our finite automata 1 comma 2. This is the uh, set of states, set of input symbols, transition function, initial state and final state also. Alright. So when we stage at 1 and input is A, we will at 1. We will remain at 1. This is transitions. Alright. 1B 2, 2A 2, 2B 1. So this is our transition function we build. Right. What is 1 comma A 1, 1 comma B 2, 2 comma A 2, 2 comma B 1. This is our transition function. So the question is Q asterisk epsilon belongs to Q. So delta, okay. So what we are saying is, sorry, I got distracted by some bullshit. Sorry for this word. Bullshit word. Sorry again. Delta 1 comma 1. This is our transition function as we can see. This is how we so next is this is let's see like this L. This is so we are giving a finite automata, all right, and we are asked to find the language, all right, the this accept, all right. So how can we do that? This is the question. So we are saying that this is our clean closure of our input alphabet. This is all string it can generate, all right. But the only strings this is accepting is which this will not accept only A out because this is B only B. All right, it can accept only B. Yes, we are going to final state, which is accepting state. All right, A A say we are not able to do that. But when we are at 1, all right, this is a string. All right, so AB is a string. First it will read A, and yes, it will remain at 1, and it will read with then B. At B it will goes to 2, which is accepting state, then AB is accepted. So all string, then we can say BB also accepted, BB, A, B, A, B. So A. So this is the language which should be end at B, right? Language should end with B, right? And with B, so this is the case. Epsilon is equal to yes. At without at epsilon, yes. Now we are back. Yes. So what we are seeing that. So we are seeing that uh, when start hold one epsilon not accept epsilon accept. So if the initial state is final, so it will accept epsilon zero length string also. Alright, it will accept zero length string. If it is not, it would not accept zero length string. This is the initial state. We can reach at initial state with nothing, with no input at all. So epsilon is also accepted. They say when we are present state is 1 and next state is 2, input is B, we will transit at 2. Right? Then present state is 1, input is B, we will transit to next state which is 2. This is a transition function we will make. Alright? Transition function what will be? 1 state, input is B, we will go to 2. Right? This is a state cross input belongs to next state. It could be one also, right? Let's say for this, the when the input is A, then it will was only A. Yes, right, right. A strict B A strict A strict A0. This is this is epsilon, right? Minimum string it can generate. This is the regular expression. So what's next? Input alphabet is of consists of two symbols A and B. Epsilon is equal to length of epsilon is equal to 0, not symbol, empty string. Alright, this means this is not a symbol. Epsilon is not a symbol. It is empty string. Right? Yes. Epsilon comma R. Epsilon is equal to one symbol. Epsilon is not empty string. Alright. Now this is the different case. When input alphabet defines that epsilon is a symbol, then epsilon ki length that length of epsilon will be 1. Right? This is now it is not a zero length string. Reached, hold, stop, and all we can say that L is equal to A comma B. A B strict set of strings. A B W W belongs to. We can define as we want. There are many lot of ways to define a string, right? A B W, or we can say W belongs to A B strict, right? This is not the case of any difficulty. I think epsilon x, what is this? 1 minimum, what is this saying? Man. Oh, we can say that it is a work as man in the C language. So we could execution start with this. Epsilon x. It will accept AX. It will accept AX. BX, yes. AAX, yes. ABX, yes. BX, BBX. All string this is. It can accept. Empty string. Fine. This is empty set, which is 5. This is a another case. This is another case. Right? A plus B strict AB strict equal to this. These all are same, right? And epsilon is equal to AB, A plus B. We can represent these two are similar. Epsilon strict is epsilon 0 union epsilon 1 union all the unions. So epsilon 0 is will be epsilon, I think epsilon itself. And it will be the A, B, and so on. Right? What this is the regular expression. What it can generate minimum is 0. What it can generate minimum is 1. And what is it can generate minimum 1. In whole it can generate minimum is 0, I think. Yes, 0. Epsilon it can generate A, it can generate C. The minimum is epsilon. So AB asterisk is epsilon, A is not. So these are different things we will see as further. Next, alright. So thank you so much. We will meet in the next video with you and take care till then. Thank you so much.